Okay, so as we said, the smallest pinion, if we take k equal, if we take k equal 54, the smallest pinion will be very small, will have a number of teeth equal 6. If we multiply by 2, it's still smaller than the allowable value, which is 13. If we multiply by 3, we get 18, which is an acceptable result. And now we can say that for us, it's fine to take to increase the value of k by 3. So to take 54 times 3, we select k equal to 162. Now, then once we determine k, we go back to our equations, replacing k by its value. We get, as expected, N4 18 and N2 equals to 27. And now we can calculate the value of N3 and N5 because we have already established that N3 is equal to 5N2 and N5 is equal to 8N2. So we can use these results to find the value of N3 and N5. As you can see here, you have N3 equal to 137. And to check, already you know that for a number of teeth larger than 18, for the pinion, for pressure angle of 20 degrees, no interference. So here you are on the safe side because both pinions were selected in a way to have a number of teeth 18 and 27. So whatever is the values of N3 and N5, it's fine for you. You don't have a problem for this. Okay, so here, but just going to the table of interference, you are in this region. You have the number of teeth of your pinion is one equal 18, one above 18, and for this region there is no interference. So whatever is the size of your gears, of course it will be accepted. It will not lead to any interference. And then once this is done, you have found the smallest possible size if you want, satisfying the conditions of your reverted train. And now, since the diametral pitch is given, you can calculate the corresponding pitch diameters of your 4 gears. So just you have to say that I know that the diametral pitch is 8, okay, and they gave me I already calculated what are the values of N2, N3, N4, and N5. So I can represent my set. I can do a figure showing that, let's say, N2 is characterized by 27 teeth. You have N3, you can put close to it 135 teeth. For here, of course, it's not to scale, okay? And here, if you want to have the exact, you should draw a new figure with exact dimensions, okay? Because you have that N2 here is much smaller than N3. And also, if you compare N2 is larger than N4. So, and N5 is, here they should switch this. Okay. هول بالعكس. N4 هي ال 18 و N5 هي, so just it's a typing error because here we have found the value of N4 is 18 and N5 144. So just you have to switch these two. Okay. So you have that N4 is 18 teeth and N5 is 144. Okay. And you can, if you want to draw a figure, you can make it a little bit to scale. So you can show the diameter proportional to the number of teeth. And now if you want to have a gear ratio of 40, okay, this means that you want to increase the angular velocity when you transmit with transmission, then the output should be the pinion and the input should be the gear. However, if you wish to have a ratio of 1/40, then N2 will be the input and N5 will be the output. Okay, so by just switching inputs and outputs, you reverse this ratio. Now, because we know all values of n, we can determine now, since we have the diametral pitch equal to 8, we can find all pitch diameters. So D2 is N2 or N2 over the diametral pitch, and the value will be in inch. Okay, you can do calculation for D2, D3, D4, and D5, and you can verify at the end that the distance center, you can calculate it in two ways, or center distance is D2 plus D3 over 2, and also it should be equal to D4 plus D5 over 2. If you do both calculations, you will obtain that both will give you same result equal to 10.125 inch. Okay. جلال قلت لكم you should switch them مغلطين فيها هن. Okay, I will fix it for you. So just take a note هون is I should switch N4 or N5. Any question on this problem? So we are done with the gear trains. Okay, the next time we'll introduce planetary gears. Okay, yeah, let's see you next time. Bye bye.
Thank you.